Yes. Okay. Good morning, everyone. Okay. In the last classes, we discussed about the linear convolution. Okay, linear convolution using two methods. What are those two methods? Overlap save method and overlap add method. Okay, overlap add method and overlap save method. If we take overlap add method, in overlap add method, what we have done? So here we have two sequences are given. In overlap add method, we have two sequences are given, x1 of x of n and h of n. See if you see the overlap add method, just we'll see once. See, this is the overlap add method. If you see the overlap add method, in overlap add method, here two sequences are given, x of n and h of n, right? X of n and h of n. Here the size of the x of n is 6 and h of n is 2. So this long sequence long sequence x of n will be uh, sectioned into the size of the small sequence. That is, x of n will be sectioned into four sections. Okay, four sections, right? So like this, we will do the overlap add method. So here we have four sections. See, four sections. X of n will be divided into four sections: x1 of n, x2 of n, x3 of n, x4 of n, like this. Okay, and h of n is already 1 and minus 1 is there. So we will do the linear convolution of these two, x1 of n with h of n, so that we will get y1 of n. Similarly, x2 of n with h of n, we will get now y2 of n, x3 of n with h of n, we will get y3 of n, x4 of n linearly converted with h of n, so that we will get y4 of n, right? So for individual section, we will do the convolution for section 1. We will get the y1 of n values like y1 of 0, y1 of 1, y1 of 2, like this. Similarly, for section 2, we will do the convolution. For section 3, we will do the convolution. For section 4 also, we will do the convolution. Finally, we will combine all these parameters, so that we will get y of n equal to x of n convoluted with h of n, that is minus 1, 2, minus 3, 4, minus 5, 6, minus 7, 8, and minus 4. In the same manner, we will do the overlap save method also. In overlap save method, here we will add zeros. Zeros will be appended. Here zeros will be appended. See here, like overlap add method, add method, it will be also sectioned into four sections: x1 of n, x2 of n, x3 of n, and x4 of n. But here h of n is given as 1 and minus 1. Here what we have done here is, here we have here the linear convolution of each section will result an output sequence consisting of 2 plus 2 minus 1. Here it is the size of the first section, it is size of the second h of n, that is 2, l plus m minus 1, that is 2 plus 2 minus 1, 3 samples. We have 3 samples. That's why in overlap save method, we will add 0, we will append 0 here, that is 1 minus 1, 1 already there, we will append 0 here. Okay, we will append 0, right? So that 0 will be appended here. So h of n will become minus 1, 1, and 0. So here we have two methods of overlap save method. So in first method, what we have done is, see here. So first of all, we will section this x of n as four sections, that is x1 of n, x2 of n, x3 of n, and x4 of n. But here in the earlier one, we have 1 and minus 1, n equal 0 and n equal minus n equal 1. For these two values, we have two two samples. But in overlap save method, here third sample will be appended. What is the third sample? That's third sample is nothing but first number of x2 of n. First sample of x2 of n. Okay, first sample of x2 of n. Right. So similarly, in x2 of n, the third sample is first sample of x3 of n. Okay. In x3 of n, the third sample is first sample of x4 of n, that is 4. Okay, if you see the x1 of n's third sample, that is first sample, that is 2 for n equal to 2. So 2 for n equal to 2. Similarly, in x2 of n, this is 3. This is first sample of x3 of n. 3 for n equal to 4. In x3 of n, that is 4 for that is the first sample of x4 of n. So 4 for n equal to 6. And what is the last sample of this x4? Here it will be taken as 0. 0 will be appended. Like you say, we will take three samples for each of n as well as these individual sections. Okay, x1 of n consisting of three samples, x2 of n consisting of three samples, x3 of n consisting of three samples, and also x4 of n will also consisting of three samples. But the last sample is nothing but the first sample of the next section. Here the last sample is nothing but the first sample of the next section. Here the last sample is nothing but the first sample of the next section. And what is the last sample here? It is nothing but the 0. Okay. Now we will perform the linear convolution. Linear convolution for the this one. Suppose x1 of n, these are the elements. It starts at n equal to 0. H of n will start at n equal to 0. So 0 plus 0. Y1 of n will start at n equal to n1 plus nh, that is 0 plus 0. It is equal to 0. Okay. Similarly, x2 of n starts at n equal to 2. H of n starts at n equal to 0. So 2 plus 0, it is 2. So y1 of n will start at n equal to n2 plus nh, that is 2 plus 0, it is equal to 2. Similarly, x3 of n starts at n equal to 4. H of n starts at n equal to 0. n3 plus nh, 4 plus 0, that is equal to 4. And similarly, x4 of n starts at n equal to 6. 6 plus nh 0, that is 6. Okay. We have to note that here n1 equal to 8, n1 equal to 8, n2 equal to 2, n3 equal to 2. So n2 minus 1 is 2 minus 1, 1. That is n2 plus n3 plus 1, 2 plus 2 minus 1. That is 3. 4 plus 1, 4 minus 1. That is 3. Okay. So here we will do the linear convolution. Linear convolution of first one, y1 of n. y1 of n is nothing but x1 of n convoluted with h of n. Right? H of n is nothing but h of, this is the x1 of k into h of n minus k. Right? N minus k. Right? N, what are n values? N values here. N values are, what are the n values here? First for x1 of n. Here the n values are, for x1 of n values are n equal to 0, 1, 2. So for these three values, we will find out y1 of n, y1 of 0, y1 of 1, y1 of 2. Right? So in the same manner, we will find y1 of 0, y1 of 1, y1 of 2. So this will be obtained by using the tabular method. X1 of k is there. So h of k is there. H of minus k is there. H of 1 minus k, h of 2 minus k. Right? So by simply substituting these values in this formula, so that we will get y1 of 0 is 1, y1 of 1 is 2, y1 of 2 is minus 3. Right? Right? Okay. Okay. In the same manner, coming to the section 2, that is convolution of section 2. So we have to find out the values of for section 2. What is the section to x2 of n? We have to find out the values for n equal to 3, n equal to, so y2 of 2, y2 of 3, y2 of 4. We have to calculate these three values. For section 3, we have to calculate y3 of 4, y3 of 5, and y3 of 6. For section 4, we have to calculate y4 of 6, y4 of 7, and y4 of 8. Right? So coming to the section 2, y2 of 2, y2 of 3, y2 of 4, we have to calculate. Right? So this is section 2. So y2 of 2, y2 of 3, y2 of 4, we have to calculate these values. So y2 of n is x2 of n convoluted with h of n, or in the formula we can write sigma k equal to minus infinity x2 of k into h of n minus k. Here n is 2, here is 3, here is 4. Okay, by simply substituting these values, so that we will get y2 of 2 is 1, y2 of 3 is 4, y2 of 4 is minus 5. In the same manner, for convolution of section 3 and section 4 also, we will find out the values. So finally, we will write the, by combining the output values of the convolution of each section. So first section we will get these values, second section these values, third section these values, fourth section these values, and fifth section, this is the final section. So these are the values. So here y of n is linear convolution of x of n and h of n it can be observed that the results of both methods are same except the first n2 minus 1 sample. So this is n2 minus 1 sample, except this remaining all values are same for overlap add method as well as overlap save method, right? Overlap add method as well as overlap save method. Okay, right? Right. So like this, we can find out the linear convolution of the given sequences x of n and h of n using overlap save method. This is one method of overlap save method. What we have done in method one, so here we are taking the third sample for for each section. That last sample will be the first sample of the next section. See, this is the last sample. This last sample will be the first sample of the next section. So here also the last sample will be the first sample of the next section. Here also the last sample will be the first sample of the next section. And here 0 will be taken. Coming to the method 2. For method 2, here this is somewhat different. This is also same as that of method 1, but here just observe it clearly. So here, suppose here also x of n, x1 of it will be sectioned into x1 of n, x2 of n, x3 of n, x4 of n, like that. But here these two samples are there. Here the third sample is taken as 0. Here the third sample is taken as 0. And here the third sample is nothing but the second sample of the first section. The third sample is second sample of the first section. Here the third sample is the second sample of the previous section. Here the third sample is the second sample of the previous section. Whereas in method 2, the third sample is the first sample of the next section. So the third sample is the first sample of the next section. Third sample is first sample of the next section. For method 2, here the third sample of the second section is nothing but second sample of the previous section. See here, this is the second sample, -1. So this is the third sample of the this section. So for this one, the third sample of this section is nothing but second sample of the previous section. So here the third sample is nothing but second sample of the previous section, and here 0 will be appended, and remaining everything is same as that of the previous method. Okay, so here x1 of n starts from n equal to 0, h of n starts from n equal to 0. So here n1 plus nh is 0 plus 0, y1 of n will start at 0. Similarly, y2 of n, x2 of n starts at n equal to 2, h of n starts at n equal to 0. So y2 of n starts at n equal to n2 plus nh, that is 2 plus 0 equal to 2. Here x3 of n starts at n equal to 4, h of n starts at n equal to 0. So 4 plus 0, 4. Y3 of n starts at 4. So here x4 of n starts at 6. 6 plus 0, 6. Okay. So remaining everything is same as that of the previous method. Only. Here also the length is 3 only, 3 samples. It consisting of 3 points. Now we will do individual doing the convolution of the each section. Section 1, section 2, section 3, and section 4. So first of all, we will take these 3 values. So y1 of 0, y1 of 1, y1 of 2. We will find out y1 of 0, y1 of 1, y1 of 2. These values. Similarly, for section 2, y1 of 3, y2 of 3, y2 of 2, y2 of 3, y2 of 4. For section 2, these 3 values will be calculated. For section 3, y3 of 4, y3 of 5, and y3 of 6. These 3 values will be calculated. And for section 4, y4 of 6, y4 of 7, and y4 of 8 will be calculated for doing the convolution of individual sections. Okay, convolution of individual sections. So first of all, we will do the convolution of first section. So that is y1 of n equal to sigma k equal to minus infinity x of k into h of n minus k. Here the n values are 0, 1, 2. So if n is 0, y of 0, y1 of 0 equal to sigma k equal to 0 to minus infinity x of k into h of 0 minus k, that is minus k. So by simply multiplying these two values, x of k and h of minus k, these two values, so that here x of k value minus 2, it is 0, 0 into 0, 0, minus 1, 0 into 1, 0, 1 into minus 1, minus 1. Okay. that is minus 1, right? Like that, we will calculate the values. So similarly, y1 of 1, so x of k into h of 1 minus k. So 1 minus k, the values are this one. So here 0 into 0, 0, plus 1 into 1, 1, plus minus 1 into minus 1, 1, plus 1 plus 1, 2. So this is 2. So similarly, y1 of 2, that is x of k into h of 2 minus k. 2 minus k values are this one. So by simply substituting these values, right? So here, uh, uh, this is 1 into 0, 0, minus 1 into 1, minus 1, plus 0 into minus 1, 0. So it is, its value is minus 1. Like this, we will calculate the values of y1 of 0, y1 of 1, and y1 of 2. Similarly, coming to the section 2, convolution of section 2, for n values 2, 3, and 4. So y2 of n equals sigma k is minus infinity infinity x of k into h of n minus k. If n is 2, it is 2 minus k. If n is 3, it is 3 minus k. If n is 4, it is 4 minus k, right? 4 minus k. So simply we can calculate the values. y2 of 2 is minus 3. For n equal to 3, y2 of 3 is 4. And for n equal to 4, y2 of 4 is minus 1. Like that, we will calculate these three values. Similarly, coming to the convolution of section 3, that is n values are 4, 5, and 6. Okay, so for y3 of 4, y3 of 4, it is 4 minus k. For y3 of 5, it is 5 minus k, h of 5 minus k. And y3 of 6, it is h of 6 minus k. Like this, we can calculate the values of y3 of 4 equal to minus 5, y3 of 5 equal to 6, and y3 of 6 equal to minus 1. And similarly, last section. Okay, we will calculate the values of y4 of 6 is minus 7, y4 of 7 is 8, and y4 of 8 is minus 1, right? Y4 of 8 is minus 1. Like this, we can calculate the values of y1 of 0, y1 of 1, y1 of 2. Similarly, y2 of 3, y2 of 4, y2 of 5. Like this, we can calculate all these values, and finally combining this all these sections, we will get the. So here last value will be cancelled. Last value will be cancelled, so that this value will not be taken into consideration. We will take these values. Why? Because here a 0 will be appended in the previous method 1. 0 will be appended at the last section, and in method 2, 0 will be appended in the first section. That's why here this last value will be cancelled. Okay, so we will take these values only: minus 1, 2, minus 3, 4, minus 5, 6, minus 7, 8. So here y of n is linear combination of x of n and h of n. It can be observed that the results of both the methods are same except the last n2 minus 1 samples. In previous method 1, all results are same except the first n2 minus 1 samples. Okay, so like that, we can do the overlap. These are very important problems. We can do the overlap add and overlap save methods. Next problem is to perform the linear combination of the following sequences by overlap add method and overlap save method. You can do this problem. Okay, here h of n is given as 3 samples. So here x of n is given as 1, 2, 3, 4, 5, 6, 7, 8, 9 samples. So x of n can be sectioned into 3 sections. 3 sections. Why? Because h of n is having the length 3. So we are dividing this x of n with the length of h of n, right? So that's why x1 of n, x2 of n, x3 of n, like this. This will be sectioned into 3 sections. Okay, so 1, 2, 3, minus 1, minus 2, minus 3. Okay, and x3 of n is 4, 5, 6. Like this, it can be divided into 3 sections, right? Can be divided into 3 sections, right? So by overlap add method, if you're taking overlap add method, simply we'll do the simple convolution, linear convolution. Okay, no 0 will be appended like method 1 or method 2. Only we'll do the direct linear convolution of x of n and h of n, right? So here n1 is 9, n2 is 3, n3 is 2. So 3 plus 3 minus 1, it is 5. We'll get 5 samples. Okay, so individually for each sections, section 1, section 2, section 3. So here for 0, 1, 2 values y1 of 0, y1 of 1, y1 of 2. Okay. Similarly, y1 of 3, y1 of like this. We can find the 5 samples for each one. Same. This is the same as that of the previous one. So we'll get the samples like this. So simply do it. Simply solving by each section, we can get the values. Okay. See, if n is 0 for section 1, n is 0, 1, 2, y1 of 0, y1 of 1, y1 of 2, y2 of 3, y2 of 4, y2 of 5 we will get. Then y3 of 6, y3 of 7, and y3 of 8 we will get. Okay. Okay. So do it individually. So if y1 of 0 is x of k into h of minus k, right? So y1 of 0 is 2. y1 of 1 is x of k into h of 1 minus k, right? It is 5. Okay. And like this, we will calculate the values. Okay. Like this, we can calculate the values, right? So coming to the section 2, so why we have calculated this 5 means here the length is 5, n2 plus n3 minus 1 is 3 plus 3 minus 1, 5. That's why we will calculate these 5 values. Okay. Next, for section 2 also we will calculate the 5 values. For section 3 also we will calculate the 5 values. Okay. Then finally we will combine all these values so that we will get this is y1 of n, y2 of n, and this is y3 of n. Okay. And this is combination of these values. So 2, 5, 7, 1 minus 2, that is minus 1, minus 3, minus 5, that is minus 8, minus 7, minus 1 plus 8, that is 7, 3 plus 14, 17, 13, 1, and this is minus 6. So this is the resultant y of n, that is a linear convolution of x of n and h of n with these samples 2, 5, 7, minus 1, minus 8, minus 7, 7, 17, 13, 1, and minus 6. Okay, that is overlap add method. Coming to the overlap save method, see. Here also it can be divided into 3 sections. Okay, but here 5 samples consisting of 5 samples. 3 plus 3 minus 1, 5 samples. So see, already 3 samples are there. Next sample is nothing but first sample of the next one, second sample of the next one. So 5 samples will be completed. So here also 4 and 5 will be here, and here last 2 samples are zeros. Last 2 samples are zeros will be appended. Okay, zeros will be appended, and doing the same here also 2 zeros will be appended here. So in the same manner we will do the convolution for section 1, section 2, and section 3. Okay. So finally we will get the combining after doing the all 3 sections, convolution of 3 sections, and then combining all these ones so that we will get so 2 sections values will be cancelled. Okay. So it is 1, 7, 7, here minus 1, minus 10, minus 7, 8, 14, 13, and these 2 will be cancelled. Okay. So this is overlap save method. Either of the methods, here we have 2 methods are there. Either of the methods we can solve this problem. So this is about the linear convolution. Next, coming to the circular convolution. Circular convolution. So by doing the problem, we can understand this concept. So see this problem. See this problem. Find the circular convolution of two finite duration sequences x1 of n equal to 1 minus 1 minus 2 3 minus 1 and x2 of n equal to 1 to 3. Here two sequences are given. Okay. So for doing the circular convolution, first point is the length of the two sequences will be same. The length of the two sequences should be same. Here, see the length of the first sequence. What is the length of the first sequence? 5. 5 is the length of the first sequence. And what is the length of the second sequence? Only 3. So we have to add zeros here. Okay. So the two sequences should have same length. So x1 of n will be 1 minus 1 minus 2 3 minus 1 and x2 of n will be 1 2 3 0 0. Here also we have two methods of finding circular convolution. Two methods of finding the circular convolution. So first one is concentric circle method and matrix multiplication. Second method is called matrix method. Okay, matrix method, right? So first we'll do the concentric circles method. Concentric circles method. Concentric circles method. See the concentric circles method. Concentric circles method. Wait, wait. See the concentric circles method. See, see here two sequences are given. Okay, so first sequence is 1 minus 1 minus 2 3 minus 1 and x2 of n is okay, 1 2 3. So here the two sequences will be the same length. Okay, so by using concentric circles, here we will draw the two circles. This is the outermost circle and this is the innermost circle. So outermost circle will be taken as x1 of n and innermost circle will be taken as x2 of n, right? So here the outer circle is a outer circle will be in counterclockwise direction and inner circle will be in clockwise direction. Suppose counterclockwise means it is anti-clockwise direction. Okay, so outermost circle is anti-clockwise direction. So taking the values of x1 of n in anti-clockwise direction. So this is x1 of 0, that is 1. Next x1 of 1 is minus 1. X2 x1 of 2 is minus 2, x3 x1 of 3 is 3 and x1 of 4 is minus 1, like this counterclockwise direction, that is anti-clockwise direction. And we will take the x2 of n values are in clockwise direction. See, x2 of 0 is 1, x2 of x2 of 1 is in clockwise direction, x2 of 1 is 2, x3 of x2 of x2 of 2 is 3. Next, x2 of 4 is 0, x2 of 5 is 0. Like this, this is in clockwise direction. Okay, this is in anti-clockwise direction. Next, multiply corresponding samples on the circle and add to obtain y of 0. So how to get y of 0? Y of 0 is by multiplying these two values, 1 into 1. Okay, 1 into 0 minus 1 into 0 minus 2 into 0, 3 into 3, minus 1 into 2. Like this we will multiply. So 1 into 1 plus 0 into minus 1 plus 0 into minus 2 plus 3 into 3 plus 2 into minus 1, so that we will get y of 0 is 8. Okay. Next, second point is rotate the inner circle in counterclockwise direction by one sample. Counterclockwise means anti-clockwise direction. Rotate this inner circle by anti-clockwise direction by one sample, only one sample. See here, this is only one sample. So y of 2 will get y of 1, so that this will be rotated by one sample. So 1 will be shifted to here, 0 will be shifted to here, 0 will be shifted to here, 3 will be shifted to here, and 2 will be shifted to here, like this. Like this, it will be rotated in anti-clockwise direction by one sample. So outermost circle will not be disturbed. Okay, only we will rotate the innermost circle by anti-clockwise direction or counter-clockwise direction by one sample only, so that we will get y of 1 and multiply these values 1 into 2 plus minus 1 into 1 plus minus 2 into 1 minus 2 into 0 plus 3 into 0 plus 3 into minus 1, so that we will get y of 1 value as minus 2. Similarly, we'll rotate this by one sample by counter-clockwise direction, so that we will get y of 2. Similarly, we'll get y of 3 and y of 4 until the end, so that y of n is y of 0, y of 1, y of 2, y of 3, and y of 4 values. Okay, we'll add those values, so that we'll get 8 minus 2 minus 1 minus 4 and minus 1. This is called concentric circles method. Concentric circle method. So what we have done here for doing the circular convolution, we'll take two sequences. So remember here the size of the two or the length of the two sequences will be same. So if it is not same, we will add zeros to the less length of the sequence. So here we have only the length is 3. So for making it 5, we will add two zeros. Okay. So outermost circle is x1 of n and innermost circle is x2 of n. So outermost circle will be in the counterclockwise direction and innermost circle will be in the clockwise direction. And for doing the y of 1, for simply calculating y of 1 value, it will be rotated in counterclockwise direction by one sample. For calculating y2 of n, it will be rotated in counterclockwise direction by one sample. Like this, will be rotated counterclockwise direction by one sample, so that we will get the values of y of 0, y of 1, y of 2, and y of 3 and y of 4 values. Like, right? So that y of 0, y of 1, y of 2, y of 3, and y of 4 values. So that we will get y of n is equal to 8 minus 2 minus 1 minus 4 and minus 1. In the same manner, we will do the matrix method also. So in matrix method, x1 of n is given as 1 minus 1 minus 2 3 minus 1. x2 of n is 1 2 3. So we will add two zeros. So it is 1 2 3 0 0. Matrix form can be written by substituting n equal to 5. So n equal to 5. So here the structure will be like this. So this is x2 of n into x1 of n is equal to y of n. So here we will arrange this x2 of n like this. x1 of n will be arranged like this: 1 minus 1 minus 2 3 minus 1. But x1 of x2 of n will be arranged as x2 of 0, x2 of 1, x2 of 2, x2 of 3, x2 of 4. This x2 of 4 can be written at here, x2 of 4, next x2 of 0, x2 of 1, x2 of 2, x2 of 3. This x2 of 3 can be written at here, next x2 of 4, okay, next x2 of 0, x2 of 1, x2 of 2. This x2 of 2, x2 of 3, x2 of 4, x2 of 0, x2 of 1, x2 of 1, x2 of 2, x2 of 3, x2 of 4, and x2 of 0. Like this it can be arranged. So first of all, we will write the values at here: x2 of 0, x2 of 1, x2 of 2, x2 of 3, x2 of 4. This x2 of 4 will be written here. After that, x2 of 0, x2 of 1, x2 of 2, x2 of 3, x2 of 3, x2 of 4, x2 of 0, x2 of 1, x2 of 2, x2 of 2, x2 of 3, x2 of 4, x2 of 0, x2 of 1, x2 of 1, x2 of 2, x2 of 3, x2 of 4, and x2 of 0. Now we will do the simple multiplication. of the matrix. Okay, simple multiplication of the matrix x2 of n into x2 of 1 into 1 plus 0 into minus 1 plus 0 into minus 2 plus 3 into 3 plus 2 into minus 1, that is equal to 1 plus 9, 10 minus 2, 8. So a1 of n is 8. Similarly, 2 into 1 plus 1 into minus 1, 1 minus 3 into minus 3, 1 minus 3 minus 2, like this. 3 into 1 plus 2 into minus 1, 1 plus 1 into minus 2 minus 1 minus 1, right? Next, 3 into minus 1 minus 3 minus 4 minus 7 minus 7 minus 7 plus 3 minus 7 plus 3 minus 4, right? Minus 4. So this is 3 into minus 2 minus 6 plus 6, okay, cancel, and minus 1. So this is y of n equal to 8 minus 2 minus 1 minus 4 and minus 1. It is also same as the result of this one, y of n equal to 8 minus 2 minus 1 minus 4 minus 1. Okay, so time is up. With this, I am concluding the today's class. So tomorrow we'll do some problems. Okay, these are